In this lesson, we'll see how the dopamine system is involved with goal-directed behavior and memory systems of the brain. So here we have the brain and some unexpected valued stimulus, or something better, right, than expected. Better than expected is registered by our nervous system. The dopamine system responds with elevated activity. And a couple of things it's going to do. It's going to signal it might signal to change goals from what we were just currently doing. Something better than expected just happened, so we'll shift our attention and form a new goal to find out more about that thing and to pursue that new thing. The memory systems will be engaged, will be activated so as to learn about the situation that just led to the unexpectedly good thing. And then we're going to store a revised value for that thing in the environment. Since it was better than expected, whatever was related to it, we want to enhance the value of that thing for future decision-making purposes. So the dopamine system is going to be involved in maintaining or switching goals, and then learning about stimuli and storing updated values about those stimuli. Now we're going to first conceptualize what it would be to sort of have a goal in one's mind, and then we'll see how the dopamine system might affect goals. So let's just imagine here we have some region of the frontal cortex, and we're entertaining three possible goals. Maybe we might form a goal of doing our homework, or maybe watching some TV, or texting a friend, or going to get something to eat, or whatnot. And the idea is there's some kind of neural competition between these goals, and the winning sort of goal will be the one that you will act on subsequently, right? So we can think of a variety of goals as sort of in competition, and the one with the strongest sort of neural activity will rise to the level of the one that you're going to act on. So we have the winning goal, and then we're going to say that our sort of attention systems are going to stabilize this goal, right, to keep us from being distracted. And you'll recall we have learned about attention systems in the past. The attention systems perform three main functions, right, to select what gets further processing, to enhance the processing of the thing selected, and then that vigilance, right, to stay focused on that, to reduce distractions, right? So we can think of this situation then is that when we've decided upon a goal, now we're going to sort of shield that goal. We're going to call this like a little information shield. We're going to shield the goal from distractions, and then we will pursue that goal. We might also make a connection to past lessons. This box here, we can think of this as sort of being the working memory system. And you'll recall we conceptualized the working memory system as a system that represents or contains what it is you're currently thinking about, and that might be a goal. But remember, the working memory system accesses long-term memories, and we pull up things that are related to what's going on or the goal, etc. So here's our situation. We've had a competition among goals. We have a winner that we now use the attention systems to stabilize this goal in our working memory, and we pursue the goal. Now, how's the dopamine system related to this? So in this diagram, here's our situation. The goal is stabilized. Our attention systems are keeping us focused on the goal, and dopamine activity, represented by just two action potentials here, is low. But now let's say we're pursuing this goal. Maybe it's doing our homework, and then something in the environment, some new stimulus arises, and it's a valued stimulus. Maybe I get a text from a friend, or a phone call, or maybe a TV show that I like just comes on, or a song. So here we have the valued stimulus. The dopamine system will be tracking that better than expected, right, that valued stimulus. And the axon sent up to the prefrontal cortex is that pathway then that has the potential to influence the goal. And so the idea is when the dopamine system detects something better than expected, the activity of the dopamine system will take down the information shield, right? So the shield is down now, and that's going to allow the prefrontal cortex systems to revise the goal, to change the goal. So there's going to be a new search. So the dopamine system is triggering a change in goals here. By taking down that sort of information shield set up by the attention systems, and now triggering a search to form a new goal. And that new goal might just be to process the new valued stimulus, or to seek out that stimulus, or learn about what caused that new stimulus. So the interaction then of the dopamine system with the goal systems in the frontal cortex is such that the dopamine system can regulate our goal-seeking behavior. If we are pursuing a goal, but something better than expected comes along, we often will switch our goal. We'll redirect our attention, and our behavior will be directed towards the new thing of value. And then we can have that new goal. We'll put the shield up with our attention systems, and we will now seek out the valued stimulus, or try to learn about what was it that caused that valued stimulus. Now, to see how the dopamine system might work in an actual animal, pursuing its daily routines, we'll consider this rat down here, this rodent here, who will explore its environment on subsequent days, and we'll keep track of what's happening with respect to the dopamine system, and how its goals may or may not change as it encounters things in the world. So let's say here we are, day 1, and the goal of the animal, it's hungry, so its goal is to go out into the world and find some food, so feeding. Now the prefrontal cortex, in our lingo here, would stabilize that goal with a little information shield, sort of, our attentions, the attention systems are going to keep that goal in mind in the working memory system, and try to reduce distractions that would interrupt goal-seeking behavior. So here goes the rat out, and we're going to follow this pathway. This is going to be day 1 and day 2. But on day 1, so it's going to come out here, it makes a left at the tree, encounters some tall grass, and what do you know? Finds some seeds. Nice tasty treat here. So on day 1, the first encounter, it's going to encounter some seeds, and sure enough, the seeds better than expected. So the dopamine system will give a little burst, and that's going to signal the brain that it just found something better than expected. It'll signal the memory systems to go ahead and search for other kinds of things that might be related to the seeds, right? So other associations. And so the memory system will store that, well, the tall grass was associated with the seeds. So in a sense, now the dopamine system is going to shift, right? It's going to transfer the value of the seeds to the value to the tall grass. So we'll have a new proxy value. So the tall grass now has a value because it was associated with the seeds. We're going to shift that value from the seeds to the tall grass. And now on day 2, let's imagine here comes the rat out, and it encounters that tree again, makes that left. Yes, it encounters the grass, and now it's going to expect the seeds, right? So if we think about the second encounter, the tall grass is now going to get the dopamine burst, but the seeds not, right, because of that value transfer. But now notice the brain of the rat may now be associating the tree with the tall grass that's associated with the seeds, right? So now we can have a situation where the tree is going to be preceding the tall grass, which precedes the seeds. The seeds originally had the intrinsic value. That value got shifted to the tall grass, but now it's going to be shifted to the tree. So next time the rat comes out here, the dopamine will respond to the tree and show reduced baseline activity for the tall grass and the seeds. In addition, in its little rat brain, this tree now comes to have value. So the memory of that particular tree will also include its reward value, and that is thought to be stored not where the visual image of a tree is, but up in the frontal cortex. So remember, we said how memories are stored in different places, different aspects of memory are stored in different places. So the visual aspect of the tree will be stored in visual cortex, but its value would be stored in prefrontal cortex. For example, orbitofrontal cortex. Now let's consider day 3, again going out with the goal of feeding. It encounters the tree, but wait, it detects a mate. So another possible mate over here. So instead of going left to get the seeds, it's going to go right and encounter the mate here. So here the idea is, while the goal of feeding was stabilized and protected and shielded, a new, better than expected stimulus came along, a potential mating opportunity, and the burst of dopamine took down that shield for the previous goal, and now you're going to switch goals. So the mate detection, you're going to get a dopamine burst. It's better than expected. And so the prefrontal cortex information shield is going to be taken down, and a new goal will arise to mate. Now let's consider what happens on day 4. So the rat's leaving home again to get some food. That's its goal. So this time it's going to go down here. Rats are curious, right? So they're going to go check out what's going on down here. So they pass by a house, and right? They hear a little ringing of the bell, and then the rat sees the cat. That's a problem, right? So we got the perception of the cat is going to be a worse than expected stimulus, right? So we would expect the dopamine activity would decrease, but again, the brain will be searching for associations, and on that travel, right, the house is going to be associated with the cat, or hearing the bell will be associated with the cat. And so now, again, the same kind of value transfer can happen. If the rat is out and about and hears the bell, then the bell will have decreased dopamine activity. The bell will be a proxy for the cat. And again, that allows the rat to make decisions more effectively, because if you can predict the cat as far away as possible with as much time as possible, then you have a better chance of escaping the cat. So in general, then, the value transfer has advantage when we transfer from the first thing that has value to other things that predict that thing. It gives more time for decision making. And in all these cases, the dopamine activity is triggering the memory systems to learn about the environment, and then to update the values of things in its memory system. So the perceptual system categorizes objects, the dopamine system is going to assign values to objects, and then the memory system makes those assigned values available for decision making.